Scenario: two blocks on a fictionless surface starts from rest and are pushed along a horizontal surface by constant force. A student will measure and record the following data. Question: which block has the greatest kinetic energy at the end of the push? To find the kinetic energy, we can use the information that is given. There's the block, the applied force, time, force that is exerted, and the final momentum. Notice that the momentum is equal to mass times velocity. So we can do that for the momentum of the second for the 2 kilogram block. The momentum is equal to 20, and that's going to be equal to the mass, which is 2, times its velocity. Dividing it, you get 10 for velocity for the 2 kilogram block. We do the same thing for the 4 kilogram block. So momentum of the 4 kilogram block is equal to mv. The final momentum was 20, divided by 4, you get 5 for its velocity for the 4 kilogram block. You're looking for which one has the greatest kinetic energy at the end of the push. Here, I can write 1/2 mv squared, and I plug in the 10 for the v, and the mass here is 2. I get the answer of 10 joules. And that is the 2 kilogram block. That actually has the highest kinetic energy at the end of the push. If you do it for the 4 kilogram block with a 5 velocity, you only get 50 joules, which is half of it. The next question: is the work done? Is there work being done here? If so, by whom and on what? Well, the block started from rest and it moves, so there has to be work being done, because to go from 0 to something, energy had to be coming into the system. So the student is actually doing work on the block by exerting an applied force on the cart in the direction opposite to its displacement. In other words, the student is pushing the block. That pushing motion by that student is the work that the student is doing on the block. The block couldn't move by itself. The student did work on it to move it. So, is the work done by the person positive or negative? Think about it. Energy is coming into the system of the block or the cart. So we can say that the work is actually positive. So you go from, if you take a look at the work equation, work is equal to the change in kinetic energy. It is the kinetic energy final minus kinetic energy initial. Kinetic energy initial was 0, and we can I think the final kinetic energy we got as 100 joules. So to go so the work is 100 joules. That is a positive value because energy had to be coming in. That student gave the block or the cart 100 joules of energy to move it. There you go.